a hill and its property. So here's the rule for the hill. There is the hill. I've got the rule over here. I'm just going to double check and make sure it looks the same as what. So I'm going to use their axes from 0 to 30. And then 0 up to 10. And okay, I agree with that. X is in meters, that's above ground. Okay, so all good. Find the derivative. Okay, so I take this line, keyboard, interactive calculation, differentiation. Okay, so that gives me it equals 9x squared minus 360x plus 2700, all divided by 2000. The set of values for which the gradient of the hill is strictly decreasing. Well, this isn't the gradient of the hill, this is the height of the hill. So what I'd like to do is I would like to graph the derivative and I can see that it's strictly decreasing for all of these values from 0 up to here. Analysis G sol min, and that is at 20. So from 0 to 20 it is strictly decreasing. So 0 through to 20, strictly decreasing is about the y value, so I'm going to have square brackets on that. Okay, so continuing on. The cable for the zip line is connected to a pole at the origin, so there's my pole, and that's 10 meters above the ground. And it's straight, so that's y equals mx plus 10, since I know that coordinate there is 0 and 10. And it joins to the curve section at AB. The cable is exactly 3 meters above the hill. So from here, it's going to be, what letter was this up here? Y. So it's going to be y plus 3. So state the rule in terms of x of the height of the cable for the horizontal, above the horizontal for, so that's from A through to there. So I'm going to call this cable equals y, which is going to be 3x x minus 30 squared on 2000 plus 3. And that will give you the rule for that bit of the cable. Find the values for x which the gradient of the cable, so it's the gradient of the cable, so dc dx is equal to the average gradient of the hill. So I can get the average gradient of the hill by doing f of 30 minus f of 10 over 30 minus 10, or I can do 1 on 30 minus 10, integral from 10 to 30 of f dash of x dx, and that should give me the average gradient, either of them. So if I take my derivative, and this is my derivative, and I bring up the keyboard, select this, math 2, I'm going to go from 10 to 30. That's going to be 1 over 30 minus 10 dx. And that gives me that value there, 10. That gives me minus 3/10. So it's equal to minus 3 on 10. That's using the average value rule of the gradient. I could do average gradient as being y2 minus y1 over x2 minus x1, and that should be, if I come up to the function, how about I define that? And then if I take that, copy, come down, fraction, paste, minus, paste over 30 minus 10, and that's 30, and that's 10, 30, and of course it's the same answer. So you can do average rate of change, average gradient, or you can do average value, get the same answer. Now the question's asked me the value of x is which the gradient of the cable is equal. So the gradient of the cable is the derivative of this, which is going to be the same as this, because it is the derivative. Because if I plus 3, it's still going to be the same derivative. So I'll copy that and paste. And I'll make it equal to -3/10, solve for x. And I get two answers, values of x. So it's going to be x equals 20 plus or minus 10 root 3 on 3. And they're my answers for x. And just interested, where are they? 14 and 25. Okay, so that's nice. It's going to be around about here and here. That's where the two gradients are equal to -3/10. Okay. Now we're looking at the last three bits, which are part C. And what part C is on about? The gradient of the straight and the curve section. So I've got a straight section that starts at 10, and that point there is point A, which, what letters did they call it? AB. So the gradient of that will be rise over run, so B minus 10 over A. That's what that gradient will be, rise over run. It goes down from 10 down to B, so that's B minus 10, and the run is A. And it has the gradients of the straight and the curve section approach the same value at x equals A. So it's a continuous smooth joint at A. Find the gradient of the cable at A, find the coordinates of point A, and find the gradient at A. Oh, so that's in terms of A. Okay, so the rule for this is going to be this. So if I copy that, now if I replace x with A, then that coordinate there is going to be A and 3A, A minus 30 squared on 2000 plus 3, which means the gradient of this line, which will be the same as the gradient at point A, will be this if I use this for B. So I wish to have B, which is that, minus 10 all over A, which I'm going to call x in this particular case. So the gradient at A is going to be, in terms of A, 3A squared on top of 2000 minus 9A on 100 minus 7 on A plus 27 on 10. Okay, so how am I going to find the coordinates of point A? Now, like a good VCAA exam, the bit before that they ask you to find is usually used in the next bit. So I've got my curve and I've got this straight line, and at this point it's the same gradient. This is an expression for the gradient along here, because I got it by using the gradient of that line. If I could take the derivative of the equation and set that equal, so d dx of, what is it again? Up here somewhere. This. So 3x, 3a, a minus 30 squared, all over 2000 plus 3, and set that equal to this m of a, and solve for a. And that should tell me where those two gradients are equal to each other. So if I've got this, which is there, and I set it equal to this, which is there, and I go solve for x, I get two answers, negative 7.85, 11.11, and 26.73. And 8 point, and we end up with a gradient of negative 0.0948 to one decimal place, negative 0.1.